This is our astronomy unit. Specifically, we're talking about the solar system, and this lesson is on the inner planets. So looking at the inner planets, also known as the terrestrial planets, we start with Mercury. It is the closest planet to the Sun. Mercury has no atmosphere. Moving away, we go to Venus. One of the characteristics of Venus is that Venus has a very thick atmosphere and a runaway greenhouse effect. Earth is the third planet from the Sun. It has life found on it, also an abundance of liquid water. And then the last of our inner planets is Mars. And Mars is considered the red planet because of the oxidization that occurs to its surface. Also remember that as we move even further out, there is the asteroid belt, and the asteroid belt separates the terrestrial planets from the gas giants. Remember, the gas giants are also known as the Jovian planets. So what do the inner planets have in common? Earth, Mercury, Venus, and Mars are more like each other than they are like the outer planets. The inner planets are small and dense and have rocky surfaces. The inner planets are often called the terrestrial planets. This comes from the Latin word terra, which means earth. The terrestrial planets all have relatively high densities. They are rich in rocky and metallic materials, including iron and silicon, and each has a solid surface. And all of them, except for Mercury, have atmospheres. Here are some general facts about each one of the terrestrial planets. Looking at each of those planets, we can see the diameter in kilometers, the period of rotation, and that's measured in Earth days, the average distance from the Sun, which is measured in astronomical units, the period of revolution is also measured in Earth days, and then finally the number of moons that each has. Looking at each of the terrestrial planets and comparing them with this data table, in the upper right hand corner of your notes, please answer the following questions. Number 1, which planet is the largest? Number 2, which planet has the most moons? And number 3, which planet is most similar to Earth in size? Again, in the upper right hand corner, answer those 3 questions. Though the 4 inner planets may have many features that are in common, they differ in size and composition as well as distance from the Sun. So let's start with Mercury. Would you like to visit a place where the temperature can range from 430 degrees Celsius to below negative 170 degrees Celsius? Mercury is the smallest terrestrial planet and the planet closest to the Sun. Mercury is not much larger than Earth's moon. The interior of Mercury is probably made up mainly of the dense metal iron. On Mercury's surface, as we can see by this picture, it has flat plains and craters. Most of these craters formed early in the history of the solar system. Since Mercury has no water and not much atmosphere, the craters have not worn away over time. Mercury has virtually no atmosphere. Because Mercury's mass is small, its gravity is weak. Gas particles can easily escape into space. However, astronomers have detected small amounts of sodium and other gases around Mercury. During the day, the side of Mercury facing the Sun can reach temperatures of 430 degrees Celsius. Because there is so little atmosphere, the planet's heat escapes at night. Then the temperature drops to below negative 170 degrees Celsius. We've done a large amount of exploration of Mercury. Much of what astronomers know about Mercury has come from space probes. Mariner 10 flew by Mercury 3 times in 1974 and 1975. Mercury Messenger has passed Mercury several times as well, and it began orbiting Mercury in 2011. Venus. Venus is so similar in size and mass to Earth that it is sometimes called Earth's twin. Venus's density and internal structure are similar to Earth's as well. But in other ways, Venus and Earth are very different. Venus has a thick atmosphere, an unusual pattern of rotation, and it is also the hottest planet in our solar system. This picture was taken by radar from some of the space probes that passed Venus. Radar is able to penetrate Venus's thick clouds and reveal the surface. The blue regions are flat plains covered by lava flows. Venus's atmosphere is so thick that it is always cloudy. Astronomers can see only a smooth cloud cover over Venus. The thick clouds are made mostly of droplets of sulfuric acid. At Venus's surface, you would quickly be crushed by the weight of its atmosphere. The pressure of Venus's atmosphere is 90 times greater than the pressure of Earth's atmosphere. You couldn't breathe on Venus because the atmosphere is mostly made of carbon dioxide. Venus takes about 7.5 Earth months to revolve around the Sun. It takes about 8 months for Venus to rotate once on its axis. Thus, Venus rotates so slowly that its day is longer than its year. Oddly, Venus rotates from east to west, which is the opposite direction from most other planets and moons. Astronomers hypothesize that this unusual rotation was caused by a very large object that struck Venus a very long time ago. Such a collision could have caused the planet to change its direction of rotation. Another hypothesis is that Venus's thick atmosphere could have somehow altered the rotation. Venus is a hot planet. Because Venus is closer to the Sun than Earth, it receives more solar energy than Earth. Much of this radiation is reflected by Venus's atmosphere. However, some radiation reaches the surface and is later given off as heat. The carbon dioxide in Venus's atmosphere traps heat so well that Venus has the hottest surface of any planet. At 460 degrees Celsius, its average surface temperature is hot enough to melt lead. This trapping of heat by the atmosphere is called the greenhouse effect. The first probe to land on Venus's surface and send back data was Venera 7, and it landed in 1970. It survived for only a few minutes because of the high temperature and pressure. Later probes were more durable and sent images and data back to Earth. The Magellan probe reached Venus in 1990, carrying radar instruments. Radar works through clouds, so Magellan was able to map nearly the entire surface. The Magellan data confirmed that Venus is covered with rock. Venus's surface has more than 10,000 volcanoes. Lava flows from these volcanoes have formed plains. More recent probes have included Venus Express from the European Space Agency, as well as brief visits by space probes headed for other planets. Images from Venus Express have helped scientists understand how Venus's clouds form and change. Earth is our next planet. There's only one planet in the solar system where you could easily live. That's Earth. Earth has liquid water and a suitable temperature range and atmosphere for living things to survive. We are known as the water planet. Earth is unique in our solar system in having liquid water. In fact, most of Earth's surface, about 70%, is covered with liquid water. Scientists sometimes speak of Earth as having Goldilocks conditions. In other words, Earth is just right for life as we know it. Earth is not too hot and not too cold. If Earth were a little closer to the sun, it would be so hot that liquid water would evaporate and would be vapor most of the time. If it were a little further away and colder, water would always be in the form of solid ice. Earth has enough gravity to hold onto its atmosphere. The gases that make up our atmosphere are oxygen, which makes up about 20% of our atmosphere, and nitrogen, which makes up the majority of our atmosphere, along with small amounts of argon, carbon dioxide, and water vapor. Like Venus, Earth experiences a greenhouse effect. Earth's atmosphere traps heat, though less heat than Venus's atmosphere. Without the atmosphere, Earth would be very much colder. It's important for us to realize that often we hear about the negative effects of greenhouse effect. We need to understand that without a greenhouse effect, our temperatures would not be suitable for life to survive on our planet. The next planet in our solar system is Mars. Mars is called the red planet. This picture shows why. The reddish color is due to the breakdown of iron-rich rocks, leaving a rusty dust behind. Though Mars is too cold for liquid water, it does have water ice, and it is thought that sometime in the past there may have been liquid water. The atmosphere of Mars is more than 95% carbon dioxide. You could walk around on Mars, but you would have to wear an airtight suit and your own supply of oxygen. Mars has few clouds, and they are very thin compared to the clouds on Earth. Temperatures on the surface of Mars range from negative 140 degrees Celsius to 20 degrees Celsius. Images taken from space show a variety of features that look as if they were made by ancient streams, lakes, or even floods. Scientists think that liquid water flowed on Mars' surface in the distant past. Scientists infer that Mars must have been much warmer and had a thicker atmosphere at that time. Today, Mars' atmosphere is so thin that any liquid water would quickly turn into a gas. So where is Mars' water now? Some is located in the planet's two polar ice caps. Scientists thought the ice caps contained frozen carbon dioxide, but recent data show that the caps are almost entirely made of frozen water. Observations from the space probes Mars Global Surveyor and Mars Reconnaissance Orbiter have found large ice deposits just under the surface as well. Some regions of Mars have giant volcanoes. There are signs that lava flowed from the volcanoes in the past, but the volcanoes are rarely active today. Olympus Mons is the largest volcano in the solar system. It is as large as the state of Missouri and is nearly 3 times as tall as Mount Everest. Mars has 2 very small moons. Phobos, the larger moon, which is about 22 kilometers across, and Deimos, which is smaller, at about 13 kilometers across. Like Earth's moon, Phobos and Deimos are covered with craters. Many space probes have visited Mars. Recent missions have focused on finding signs of water and possible life on Mars. Rovers called Spirit and Opportunity found traces of salts and minerals that form in the presence of water. The Phoenix mission took samples of soil and found frozen water near the North Polar Cap. Orbiting spacecraft, such as Mars Express, have detected methane gas in Mars' atmosphere. This gas might be a clue that microscopic life forms exist on Mars even today. It's important to recognize that when we have people searching for Martian life, we are not necessarily looking for things that are complex. We're looking for things like bacteria or algae growing on the surface or slightly under the surface.